Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We are moving on to 2.4, which will be broken up into 2 days, I believe, is what we're going to go shoot for. So we're going to talk about graphing lines and writing the equations of lines first, then we're going to move into direct variation and linear models for part 2. Okay? So the name of the lesson is writing equations of lines. Our essential questions are: be able to write an equation of a line given slope and y-intercept, be able to write an equation of a line given a point and a slope, be able to write the equation of a line parallel or perpendicular to a given line, be able to write an equation that shows direct variation, be able to determine if data shows direct variation, be able to write a linear model from a real-life situation. All right, so we have a review of concepts. It says slope-intercept form, y equals mx plus b. Hopefully you know y equals mx plus b from middle school. That was a very popular one. And then in Algebra 1, we learned about point-slope form, which was y minus y1 equals m times x minus x1. This is actually from the equation for 2 points, okay, which is this. It's going to be m equals slope formula, y2 minus y1 over x2 minus x1. So what happened here? Well, point-slope form is taken just by multiplying both sides by x2 minus x1. You don't need to write this down. I'm just going to show you. x2 minus x1. Oops, that's not a 1. Okay, and these cancel out, so that's where we get the y minus. It's actually, well, it's y2, but it's just replaced with a y here, okay? So the point-slope form is taken by just taking the slope formula and multiplying by x2 minus x1 on both sides, and then changing it to just y and x, and not x2 and y2, basically, okay? But I just want to show you that brief little thing there where that comes from here. But it's basically just using the slope formula in a different way. All right, example 1 says write the equation of a line that has the given slope and y-intercept. Well, with these problems, you want to do exactly what you have. You want to use the type of equation for exactly what you have. We have a slope and we have a y-intercept, right? We have an m and we have a b. So what formula do you think we're going to use for this? Probably slope-intercept form, right? We've got an m, we got a b. We're probably going to use that one for our for this problem. So let's go ahead and plug it in. We're going to do y equals mx, which is negative 4 times x, plus, or b, which is negative 7. So I'm going to put minus 7. Y equals negative 4x minus 7 is y equals mx plus b form, which is a equation of a line. There we go. Easy peasy. All right, example 2. Now we're making it a little bit more challenging here. It says write an equation of the line passing through the given point and has the given slope. Well, we have a point and we have a slope, so what do you think we're going to use for this problem? Probably point-slope form, right? I would agree. We're going to use point-slope form, but, and actually you could leave it at point-slope form, but I think for these kind of problems, I looked in the book and stuff, and I think they want you to write it in slope-intercept form later, which we'll talk about in a second, but let's go ahead and do point-slope form. So we got to label this our point x1, y1. Then we're going to plug into that formula up there. We're going to do y minus y1, which is 6, equals m, which is 3, times x minus x1. So what's x minus negative 2? Minus a negative, the same thing as plus a positive, so we get x plus 2. So actually, I don't like that they want you to really solve it, get it to equal y equals mx plus b, because this is an equation of a line. This is as far as you need to go, but just to humor the book and what we might do in our tests and stuff, we will go a little bit farther here, okay? So we're going to take this a step farther. That is an equation of a line right here, but we're going to go ahead and we're going to get y by itself to get y equals mx plus b. So how do I get y by itself? What would be a good first thing to do here, do you think? First thing I would probably do is distribute the 3 to both of these, right? So we're going to get y minus 6 equals 3 times x is 3x, and 3 times 2 is 6. Remember the distributive property, very important property. All right. And now what's the next step to solve for y? We need to get y by itself. We have y minus 6. To undo subtracting 6, we need to add 6 to both sides. So we're going to get y equals 3x plus, what's 6 plus 6 going to be? That's going to be 12. Now is it y equals mx plus b? We all solved? We are good. There's our final answer. All right. Now, number 2, same kind of thing, but we have a weird fraction slope for this one. So we're still going to plug into y minus y1 equals m times x minus x1. We're going to label our points x1, y1. We're going to plug into y minus y1, which is what? That's going to be 2, equals our m, which is negative 2/3, times x minus x1, which is going to be 5. So I was solving this earlier, and I was thinking about how I would approach this. Usually we like to fraction bust with this kind of stuff and multiply by 3 on both sides, but eventually you're going to have fractions anyways, so I would not fraction bust for this. I would probably distribute this negative 2/3 to both of these, okay? Let's distribute both of these here. So we're going to get y minus 2 equals negative 2/3 x. What is negative 2/3 times negative 5? Well, negative 2 times negative 5 is positive 10, and 3 times 1 is going to be 3. All right. Now we need to get y by itself here. How do we do that? We need to add 2 to both sides. So I'm going to go over here. I'm going to do 10/3 plus 2. Okay, I need to convert, we need a common denominator here to add these fractions, right? So we need 3 be the common denominator times 3. So we're going to get 10 over 3 plus, oops, my meeting ended here. Give me 1 sec. All right. Sorry about that. Just been keeping an eye out for office hours. What's 2 times 3 going to be? That's going to be 6 over 3. So it's 10 plus 6 is going to be 16 over 3 is going to be our new problem here. So we're going to have y equals negative 2/3 x plus 16/3. So if you were to fraction bust here, you would just get right back to this original problem. So it doesn't make sense to do it there for that problem, okay? All right, moving on. Example, just this example, no number on it. So it says write an equation of a line that passes through negative 3, 5 and is parallel to y equals 7 minus 4x. Okay, so well, we're going to pass through this point. We're going to label this x1, y1, right? We're going to use that for point slope form probably. But what kind of slope are we going to use? It says it's parallel to this line. We have y equals 7 minus 4x. Well, parallel lines have what kind of slopes? Hopefully you said same slopes, okay? So what's the slope of this equation? They kind of wrote it weird. They wrote it backwards. What's the slope? Is the slope 7 or negative 4? The slope is actually negative 4. That's our m. Okay? If we were looking for a line perpendicular to that line, what slope would we use? We wouldn't use negative 4. We would use the opposite reciprocal of negative 4, which would be 1/4, right? So be careful what it's asking here. If it's asking for parallel, you're going to use the same slope. If it's asking for perpendicular, you're going to use the opposite reciprocal slope, which means flip the fraction and change the sign. But for this one, we don't need to worry about that because we're just doing parallel. So we're going to plug into our point slope form, which is y minus y1 equals m times x minus x1. I would encourage you to memorize these equations. I'm not sure what we're going to give you to be able to use on the test or the quizzes, so make sure you memorize those. Let's plug it in now. We got y minus y1, which is 5, equals negative 4 times x minus x1. So x minus negative 3 is x plus 3. All right. Now we got to solve here. How do we solve? We need to distribute, right? So negative 4 times x, negative 4 times 3. Y minus 5 equals negative 4 times x is negative 4x. Negative 4 times 3 is negative 12. Last step is to add 5 to both sides. Y equals negative 4x minus 7. And there's your answer. That's your points or slope intercept form. But like I said, this right here is an actual okay answer for a equation of a line. So I take exception to the book's stance on that. But anyways, not a problem. I'm not in charge here. So a couple more examples, and we're going to stop. Direct variation is going to be part 2. So we're almost done here. Stay with me here. All right, so before we took something we had slope and y-intercept, we wrote it in slope-intercept form. Then we worked on writing it in point-slope form and converting it to slope-intercept form because we had a point in the slope. This one right here says write an equation of the line passing through the given points. This one, they just gave us 2 points. They didn't give us the slope. They didn't give us the y-intercept, so we have to find both of those things, okay? So we're going to label these points. We're going to use the slope formula, which was m equals y2 minus y1 over x2 minus x1. So So we're going to label our points x1, y1. Each point needs an x and a y, x2, y2. You could also reverse these if you wanted to and call this one x2, y2 and x1, y1. That's totally fine. But I just like to go in order usually. So, all right, so we're going to plug into the formula. Slope m equals y2, which is 2, minus negative 8 is going to be plus 8, over 8, which is x2, minus x1, which is 3. So 2 plus 8 is going to be 10, over 8 minus 3, which is 5. 10 divided by 5 is going to be 2. So our slope is 2. Now we're going to go to point slope form. Okay, now we're going to use the, like I said, the y minus y1 equals m times x minus x1. Now we're going to plug into that, but you can use either point you want. You can use either point you want. Which one do you think would be easier to plug in, the 3, negative 8 or the 8, 2? I'd probably use the 8, 2 because those are both positive, right? So we're going to do y minus y1. This is actually going to become y1 if we do that, right? When you're plugging into this formula, you don't do y2 and x2. You just have y and y1, basically. But you can. So what I'm trying to say here is you can pick either point to be your y1, x1, basically, or x1, y1, okay? So you can use this one that confuses you a little bit, but either point you can take and you can plug in for here and in for here, okay? So y minus y1, I'm going to stick with the point 2, is y minus 2 equals m, which is 2. That was our slope right here. And then we have x minus x1, which is going to be 8. Okay? So now we're going to distribute like we usually do to get y by itself. Got to distribute first to simplify. 2 times x is going to be 2x. 2 times negative 8 is negative 16. Last step to solve for x is to add 2, or solve for y, I'm sorry. So y is going to equal 2x, and then negative 16 plus 2 is negative 14. So this is kind of putting everything together here. Why don't you guys go ahead and try number 2, and just be aware, you're going to get a weird result here. Give it a try, but you're going to get a weird result. See if you can figure out what the weird answer is going to be at the end. All right, welcome back. So we're doing the same thing. We are x1, y1, x2, y2. We're going to go ahead and find the slope, and then we're going to figure out what the equation of the line is going to be. So m equals y2 minus y1. We have 3 minus negative 2 is 3 plus 2. Over on the bottom, we have x2 minus x1, which is going to be 4 minus 4. So 3 plus 2 is going to be 5. 4 minus 4 is going to be 0. Uh-oh. Can we divide by 0? We cannot divide by 0. So is this slope going to be 0 or undefined? This is going to be undefined. Okay, so an undefined slope, if I don't know if you remember Hoy-Bucks. Hoy-Bucks, I need you to remember this. A horizontal line has a 0 slope. It's y equals a number. A vertical line has undefined slope, and it's x equals a number, what the equation is going to look like. So this one, all we have to do for this one, if it's a undefined slope, well, all we have to do is our final answer is going to be x equals whatever the x coordinate is. What's the x coordinate for both of these? It's x equals 4. Our final answer is going to be x equals 4 for this one. If we had a 0 slope, it would be something like y equals 2 or something like that. So remember, horizontal line is going to be y equals a number. Vertical line is going to be x equals a number. You just set it equal to the x coordinate or the y coordinate, basically. Okay? So horizontal line, 0 equals the slope, right? And then vertical line, undefined equals the slope. So we have an undefined, we're doing this right here. This is an undefined line, undefined slope, so we're going to have x equals a number, and the number is going to be 4 because that's our x coordinate for this here. So the equation of this line is going to be x equals 4. Kind of tricky. Hopefully you got that. If you didn't, don't beat yourself up too bad. It's pretty tricky. And thanks for watching. We'll continue with part 2 probably the next day. So have a great day.